Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with lesson number 9 in our incredible new tutorial series where you're going to learn Fusion 360 or you're going to die trying. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 8. And that was to create a dandy little case for your eyeglasses. So my question for you is, how many of you were successful? Be honest. If you were successful, leave a comment down below. I am legend. And if you were not successful, leave a comment. I folded up like a cheap Walmart lawn chair. I guess there's a worse thing than folding up like a cheap Walmart lawn chair. The worst thing is option number 3. I never entered the arena. Okay, so if you succeeded, great. If you failed, great. If you didn't enter the arena, man, get in there and start trying to do these homeworks. The homeworks are really important because when you watch me do them, they look really easy and you understand what I'm doing. But just because you understand what I'm doing when you watch me do it, that doesn't mean that you can do it on your own. So to see if you're really understanding this stuff, you need to do the homework. So leave some comments down below. Also post your solutions to YouTube, and then in the comments down below, leave a link over to your solution. And I do go in and look at every single homework solution that you guys post to YouTube. Okay, way too much talk, not enough designing. So let's get into these lessons. One of the things that I really want you to learn today is how to think like an engineer. It's just like when we were doing the coding. What did I always tell you? Sketch it out on paper before you start writing the program. Same thing in Fusion 360. Sketch it out on paper before you do it in Fusion 360. But now what I want to do is let's just take a quick glance over here. Let me get out of your way. And let's take a quick glance over here. This was kind of like the little concept that I showed you that I wanted you to try to design as your eyeglass case. And so that is sort of what we're going to be working towards today. But what I need us to do is I need us to kind of go in and see if we can sketch this thing out before we jump in, to Fusion 360. And so let's come over here, and what I'm going to do is see if I can get the old sketch pad configured in a position where I can conveniently access it. And I think that is going to be pretty good. And then the first thing that we're going to need to do is kind of dimension the box. Well, it's helpful to have my glasses here, and it's helpful to have a ruler. And so we're working in millimeters, so I'm using the millimeter side of the ruler. If I come here and look at these glasses on the ruler, what I can see is for my glasses, if I make the height of this case, if I make the height 140, that will hold my glasses very well. Now I have 2 other dimensions. I need to measure it this way. Okay, measure it this way, and it looks like about 40 would be a convenient fit. And so I'm going to say the length is 40. And now I need to measure it this way. And so if I measure it that way, it looks like 30 would hold it very well. So I'm going to have a width of 30, I'm going to have a length of 40, and I'm going to have a height of 140. Now, even though I have those dimensions written down, What I really need to do is go in and create a little bit of a sketch, so then as I'm designing, I'm not just looking at numbers, but I'm looking at a little bit of a sketch. So I'm going to try to do a little bit of a perspective drawing here. It's not going to be great. It would certainly fail any art class, but I'm going to kind of come down and see if we can create a little bit of a perspective drawing like that. And then this one will be here like that, like that. Okay, we got a little bit of a perspective drawing. Now you saw I had a top and I had a bottom. Okay, so I had a cap and I had a base. All right, so what is something that we know? We know that from here to here is 140. Now what you can see is you can see that there's a seam here. So what we got to think about is out of the 140, how much do I want to be base and how much do I want to be cap? Well, I think what I want is I want to make this 100, okay, and then what I want is I want this to be 40. So if I take the 100 from here to here and I add the 40 from here to here, I get this, which is 140, which is what I want. Okay, the good news is I have the rough sketch in there, but what you know is you know that there's a second seam and that there is that overlap region. And so we got to think really carefully about these dimensions, because it's a pretty simple thing, but getting all the dimensions in the right place, you do have to think a little bit and you got to be careful. So now in the sketching, I'm not going to be trying to maintain that perspective view. I'm just going to do a cross-sectional view, and I'm going to see if I can figure out where that lip is and how much the overlap is and things like that. I've determined, what have I determined? I've determined that the seam is here at the 100 on the bottom and the 40 on the top. That is what I have determined. But now we need to come over here and we need to figure out more specifics. So I'm going to start with the base. Okay, I am going to start with the base. All right. And what I want is, yeah, you can see that. What I want is I want to draw it like this, and I'll come out here. Okay. Now what you have to remember is on the base, that lip is on the inside at the top and the gap is on the outside. So the gap is on the outside, so I'm going to come up so far, and then what? I'm going to come over, and then I am going to go on up, and then I'm going to come over, and I'm going to come down. Now I am just drawing this as a shape. Once I get the shape done, I've got to think, and then I will write the dimensions on there correctly. We'll finish this side over here, and we'll go up, it goes over, it comes down, it goes over, and it comes like this. Again, I do not want to put dimensions on there yet. I want to sketch both parts. So now I'm going to need to sketch the other part here, and it's going to be shorter, but what is different? Okay, what is different about this one? This one's going to come up, and that shelf, that ledge is going to be on the outside, and the gap is going to be on the inside. Okay, the gap is going to be on the inside. Okay, now can you see that this part can slip fit over that part? Because this one has the gap on the outside, and this one has the structure on the outside, and this one has the structure on the inside. So they will slip over each other. Now what do I know? I know that the base, the part of the base that matters from here to here, from here to here, needs to be 100. Where is that on this picture? It is between here and here. Okay, that needs to be 100. All right, now from here to here, up here, this 40, where is that 40? That is from here all the way down. That is 40. So that is quite annoying. Get out of here. How do I make that go away? I get it out of the way. Okay. So I know that from here to here is 40, and that's the same as from here to here. And then I know from here to here is this 100. So then the whole thing is going to be 140. But now there is something that we have yet to determine. We have yet to determine and let's see if I can get this. We have yet to determine this overlap region. And that overlap region could be small or it could be big. And those outside dimensions of 140, they say this stay the same, but the overlap region we can define and still the outside will work. And so what has to happen though is this has to be the same as this. And so I think an overlap of 20 millimeters would be good. So if this is 20, what does this have to do to match it? To match, it has to be 20. So this 20 and this 20 will match. Now, what does that mean then? That this dimension has to be, well, it's the 100 plus the 20. This one needs to be 120. Okay, now this we go the other way. If from here to here is 40 and from here to here is 20, then what is left over here? 20. So this 20 and this 20 adds to 40. This 100 and this 20 adds to 120. Now this seems so easy, but believe me, if you don't draw it out, you ain't going to be able to design it. And I'm going to fess up. When I did my preliminary design, you know what I did? I jumped in and I designed it without sketching it because I'm a pro. And then when I got there, I hadn't done it right in my head. So what I want you guys to see is even if you are very, very experienced, what you need to do is you need to sketch it out. Now, the other thing that I will say is I hope that you sketched along with me, because as we design, I'm going to keep going back. I'm going to keep going back to this sketch to add my dimensions on there. All right. Ooh, that was probably a loud, ugly noise for you guys, but that was probably a loud, ugly noise for you guys. All right. So that's looking pretty good. Let me come back over here and let's come to our design view again. And I'm going to come up and I am going to say a new design. Okay, so we're going to start with a fresh new design. And what will we start with? We will start by creating, and we are going to create a sketch. We're going to use the XY plane, which is the red-green plane. I'm going to start with a rectangle. I will click, release the click and drag. And now I need to look back at what? At the sketch. And what I see is the length is 40. So I type in 40. I tab to the other dimension, and that is 30. Like that, and boom, I have the start of what I need to create that eyeglass case. Now, this box that I've shown, do you want your box to have a very sharp, hard corner that might cut someone's thumb, might cause an injury, product liability? No, I want to round that off nicely. And so what I am going to do to round that off, my friend, is the what? Is the fillet. So I'm going to say, give me this and give me this and give me a fillet. Give me this and give me this and give me a fillet. I see that I'm getting warnings over there as I do this, but if I look, I'm not fully constrained, but I'll not panic yet until I get this finished. It's not fully constrained because I haven't put a dimension in. And so I'm going to say this and this will be filleted, this and this will be filleted. And now I need to decide how rounded it should be. That 10 millimeters looks a little bit too circular to me. Let's go to 5. That looks a lot better. Let's go to 1. 1 is almost square. I'm going to look at 2. I want a little more than that. Maybe I should zoom in so you guys could see. You guys could see it. All right. I'm going to try 3. I think 2 is perfect. Okay, so I'm going to do 2. All right. Once I put in 2 and I entered, my sketch is fully constrained, and so that's really good news. Now, I need to redraw this slightly bigger so I can have something to extrude. Yes, I could redraw the whole thing, but what would be easier? Who is our tool that we learned about last week? What is that tool that we learned about last week? That tool is our friend offset. Okay, now what do I want to offset? I want to offset this. Now, the thing that I drew that was 40 by 30, is that the outside of the container or is that the inside? We measured the glasses and we want it to be to the inside, because if we have a thick wall, then the glasses wouldn't fit. So that dimension is the inside dimension, which means we want to extrude out. And one thing we didn't talk about over here, the one dimension we didn't talk about, we need right now, and I should have done this, but let's see if we can recover here. What we need is we need to see the wall thickness. And I want the wall thickness to be 3 millimeters. Okay, so if that's 3 millimeters, this will be 3 millimeters, this will be 3 millimeters, and this will be 3 millimeters. Well, then what is this? That is going to be half of 3 millimeters, 1.5. What is this going to be? Half of 3 millimeters, which is 1.5. So you could think of it as a 1.5 wall and a 1.5 gap. And then over here, a 1.5 wall and a 1.5 gap. So one guy's wall matches the other guy's gap. One guy's gap matches the other guy's wall. And therefore, we will get a smooth slip fit of those two on top of each other, if that makes sense. So I am going out, when I come back over here, I'm going out by how much? 1 point, I need to click on here to get that selected. Okay, 1.5, like that. And enter. And I'm going to check over here, I am fully constrained. Now, the question is, I need that other one, because if we look here, if we look back over here, I cannot do this. I cannot do this with one extrusion. I have to extrude this part, and then I have to extrude this part. So I need 2 extrusions. If I need 2 extrusions, how many offsets do I need? I need 2 offsets. Now you could think I could take this and offset it by 3, or I could take this and offset it by 1.5. Now, your natural tendency might be to take this outside one and do 1.5, but I'm not going to do that. I drew the inside one. I know what the inside one is about. I'm going to offset the one that I drew. I was saying extrude, I meant offset. I'm going to offset the one that I drew, because I don't know what type of craziness they might have done when they did the offset. So I'm going to go back to the one that I know is clean, and so I'm going to come in and I'm going to say offset. I'm going to select the inside one, and I offset not by 1.5, but I am going to what is that? Oh, I see. Never mind. Hold on. You got to click off of everything. With nothing selected, you're going to come in and say offset, and then I am going to select the inside one to offset. I'm going to offset it by 3 and enter, and look at that, giddy up, fully constrained. And I have kind of a little bit of a, getting to be a pretty sophisticated little sketch here. Now we need to go to the right, and we need to start from scratch and draw this again, right? No, what we're going to do is we are going to select it. We are going to right mouse click and we're going to say move copy. Now I would not be able to move it. I would not be able to move it. Why? Because it is locked to the origin. So what I need to do is I need to say create a copy, right? I need to say create a copy. And when I say create a copy, it should allow me to move that copy. Now, I don't want to try to put it, okay, I do not want to try to put it in a particular location. I just want to kind of put it somewhere random, because if I put it in the exact position, still it is not going to be a fully constrained model, because it's not about putting in the right position, it's about locking it in the right position. So I'm going to kind of just put it over there, and that way I can create a point to jump over to. So what I'm going to do is I'm going to give myself a point to constrain to, and so I'm going to create a construction line. So I select line, I come over here, I say constraint, make it a construction line. I come here to the origin. Let's make sure I can lock to the origin. So there, I'm on the origin, and I will come over here and I am going to deliberately put in a dimension of 50. And when I do that, this construction line is fully constrained. And so now I need to find a convenient point over here. And it looks like, let's see, it looks like I could take that point. And then if I took that point and I constrained it to this point, then everything would be locked down and these would be kind of equally horizontally aligned. And so what I'm going to do is I'm going to click off. I'm going to get my coincident constraint. I am going to select this point and say that I want that consistent with, coincident with that point, and boom, I got it. I'm always a little nervous when I put those constraints in there because they don't always do exactly what I was expecting. All right, good news is we are fully constrained. All right, so we can finish our sketch. I like to go to the home view. And now what I need to do is I need to start my extrusions. So let's just take a second. And I like to start on the inside and extrude starting. So how many extrusions do I have to do on this one, let's say on one part of the sketch? 3. I need the bottom plate, then I need the inside shell, and I need the outside shell. I like to start on the inside and work my way out, because you can create a body that then makes it hard to go in and select your sketch. It's almost like you hide your sketch, okay? So I like to start on the inside and then I like to work my way out. So what do we want to do? We want to extrude. What do we want to extrude? This bottom plate. And then how far is that extruded? Well, let's just take a quick look over here to remind ourselves. And right, we said that that was 3 millimeters. And so we can come back and we know that that is going to be, if I select it to make sure, 3. Okay, boom, we have that done. Turned my sketch off. Thank you very much. I will turn it back on. And now I need to extrude this. Well, what do I want to do here when I extrude that? What do I want to do when I extrude that? I think it would just be a good practice to say extrude. What do I want to extrude? I got this, and I want to extrude it one side, and I want to extrude it to an object, and then I make it match that object, and I say okay, and look at that. Now if I ever change the first one, it would also change the what? It would also change the second one. Now remember, this body on your left, is the base, and so the next thing that I am going to extrude will be basically this here. This one is what I am going to extrude now. Let me see if I can get a color. This is what I'm going to extrude. And what should that extrusion be? I've got it labeled. It should be 120. It's the inside one is going to be 120. And so let's come back over here. And what is it? It is the inside one Okay, sometimes you got to zoom to collect it. Okay, that one is going to extrude how far? It is going to extrude 120, and then I click enter, and there I have it. Okay. I am having trouble making this do what I want. There it is. Okay, so that was 120. Now what is the outside extrusion going to be? The outside extrusion is going to be 100, right? This is what we're going to extrude now, from here to here. And that is what? That is 100. Yeah, that is 100. So I will come back over here. I'll zoom in so we can select it. Zoom in so we can select it. Okay, and now that we are going to extrude to what? 100. Like that. All right, now let's take a look at that body now. Okay, wow, look at that, exactly what we wanted. Now we need to come over and we need to do this other body. We're going to start on the inside. We're going to zoom so we can get it. There, I got it. Now we're going to come back over here, and that is the inside, and the inside is from here to here. That is this dimension, which is what? 20. So we are going to extrude that one by 20. All right. There it is. Extrude that one by 20. And now we have to extrude this final one. And we'll come back over here. And that one was what? That one was 40. All right. So we will come back over here. We will extrude that one by 40. Enter. And look at that. Okay, do you guys see what we've just done? This is going to plug into this. They're going to match perfectly, and it's going to come down to a smooth seam. How cool is that? Okay, that is pretty darn cool. Now you guys that are OCD are going to see that I kept track of dimensions very carefully, this way and this way, but when I extruded those things to sum to 140, I didn't take into account the wall thickness of the top and the bottom, and so that 140 is going to be an outside dimension, but the 30 and the 40 are going to be inside dimensions. But that's okay. That will work out just fine, because the glasses are going to have plenty of room to fit in there. Okay, so what do we need to do? We need to come up and we need to save this. Okay, and so I'm going to say glass case, like that, and say save. And then after I save it, what I am going to do is, takes a second to save, I'm going to come in and I am going to export it, and I export it as glass case version 1, and it needs to be a what? It needs to be an STL file. I can't tell you how many times I forget to change that to STL, and then I will export, and it usually takes a second or two to export. And while it's doing that, I will open Cura, our slicer. Takes a second for Cura to fire up. Let's bring this over here. All right, so what I need to do now is I need to go get my exported file, and I will have to do a little bit of navigation to get there. And okay, so I found it, and I can bring it over, and I just drag and drop it like that. I drag and drop it, and boom, there it is. Let's look at that. That is really quite beautiful. And so now we are ready to slice it. Now guys, if you are like me thinking anything that is worth doing is worth overdoing, you are tempted to come over here and go to super duper double deluxe high ultra quality, but really standard quality is plenty good. And when you do standard quality, it prints a lot quicker, and when you're printing quicker, it is a lot less likely that you're going to have an adhesion problem to the bed, or you're going to have a power outage or whatever. So really, you know, if you don't need it, don't go at something that's a much greater precision than what you need. And really, these edges are very smooth without going to the higher quality. So we're going to do standard quality, and then I guess I need to make this where you can see it. All right, and then got the standard quality. I'll do slice. Now in future lessons, we're going to start tweaking these parameters as we start getting more complicated and more intricate designs. We'll start playing around and tweaking these printer parameters, but for right now, what we're doing is we are just going with the defaults. Okay, so we can do that, we can save it, and then after we save it, then what we need to do is we need to go get it, and we need to put it on the SD card, and then once it's on the SD card, we put it in the 3D printer. And then once it's in our printer, then we select print. But I already showed you that in an earlier lesson how to do that, so you don't need to sit and watch me do it. Plus, I had actually started this print at the start of the lesson, anticipating that we would want to kind of see it. And look at that. Is that not a lovely little glasses case that is coming together? Now, I even want to show you, if I can get this silly thing to focus, if you look down over on the right, which is being covered up right now, over on the right is the top cap, and you can see that it is already printing that ledge. Do you see the ledge in there? Okay, it is printing that ledge. So we got past the double wide wall, and we're now to the single wide wall, and probably very, very soon that cap piece on the right will be finished, and then it'll just be working on the base on the left. So I think that that is just absolutely super cool. So what I'm going to do is, one of the other things, okay, I'm going to pause the video, and then what I'm going to do is, after I pause the video, I'm going to let the print finish, and then I will come back and we're going to play around with it a little bit. I'll say a couple of words here, and those couple of words I will say is, I'm sure some of you are thinking this, that I did not leave any tolerance, right? I did not leave any tolerance. The outside diameter of the cap is exactly the same, or the inside diameter of the cap is exactly the same as the outside diameter of the base. So is that going to slip on there, or should I have left a little tolerance? The whole thing on design rules, will be a lesson that I will do in the future. But for right now, what we've done is we've just done a design with no tolerance, and we sort of hope that it is going to work. And then in future lessons, we will more formally design and print structures that will allow us to very formally determine our design rules, and then we'll be able to do things in the future. But I want to get us designing and printing and designing and printing, and then we will become more adept at it in the future. And look what I see here. By the magic of pausing the video and now rejoining it, what I see is our print has finished. Boom, look at that. So let's see if I can get it off. What I've seen, I don't know if you guys have noticed this. I don't know if you guys have noticed this with the Creality Ender printer, but what it seems like is if you let the build plate cool down, the parts auto release off of it. They just release. But I have just finished this print, so they haven't auto released. And one way I like to get rid of them, I don't like to come down here and try to pry them off from the bottom because it's very easy to scratch the build plate with this scraper. And so what I like to do is I like to just try to knock them off like this. Boom, look at that. Okay, and now the moment of truth. We are going to come in here and we are going to put this here, and look at that. That, without using any tolerances, this is what I would call a very snug fit. It's one that it's not going to come off, and it goes on and off fairly easily, and so I am really, really happy with that fit. But now, of course, the question is, we will return to the river cam here. You see we're kind of getting to sunset over the old Nile River. But let's see if the glasses fit. Let's see if we designed it properly. The glasses go in, and they are a little bit up there, but that's okay. Remember, I've got that 20 millimeters up here, and so I can go like that, and boom, I have a handy dandy designed myself and 3D printed custom deluxe case for my eyeglasses. Okay, guys, let me know if you were successful, and let me know if you are enjoying these lessons. As we're moving forward, I want to push you forward in your design capability, and then I want to pause and I want to push you forward in your printing capabilities. On a 3D printer, as it comes from the factory, it's very easy to print small, simple things. But as we begin to design more complicated things, we have to improve our print skills, which is not just techniques like tweaking parameters in the slicer, but it's also coming in and working on our 3D printer to improve our ability to level the bed, improve our ability to align things, and a lot of different things like that. What I will say is I know a lot of you guys are interested in auto bed leveling, but that's not the first upgrade that I would make to this printer. Over time, we're going to be doing upgrades, but a lot of the first upgrades are the ones that you're going to get the maximum benefit for the minimum investment. And so that's one of the things that I will be doing over time. For just a few coins, we'll be able to really get a lot more performance out of our Creality Ender printers. Man, guys, I hope you're having as much fun taking these lessons as I am making them. Really appreciate you guys tuning in. Really look forward to the premieres with you. And I have a faster internet connection now. I'm going to start trying to do more live streams. So really appreciate you guys. Love you guys, and want to say thank you, and appreciate it if you would give me a thumbs up. Leave a comment down below as well. That helps me with the old YouTube juice, and that will allow YouTube to show these videos to more people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.